also, you may have it written in this format.
Oh, that's a good change.
Okay, if you actually rationalize that. And the thing with this homework is like all those problems, like I said, it's very easy to maybe have the correct form of an answer, but then there's also alternate forms that are correct as well. So if you think you did something right, plug it into your calculator and see if it matches up the decimal for that. And now for C, I'm sure, I think even in the book, they didn't have this one, but that was a one I got using a different method. I think they just have the square root of 13 plus 3 over square root of 13 minus 3. I think they have that for the tangent. Because if you did the sine over cosine with that, you could end up equaling that.
The back of the book had a different answer.
Then that?
Yeah, it was 13 plus 3 square root of 3, and then 13 minus 3 square root of 3. So it was exactly the tops of those two.
13. Oh, right here.
Yeah.
And then right there.
Yeah.
So 13. All right. So yeah, because they. All right. So let me. So 13 plus 3 square root of 13, like you said there.
Yeah.
And then 13 minus 3 square root of 13. For that. Okay. So that would also be equivalent. And so I said I got it a couple different ways here. I forget which formula I used to get that one or how I went about it.
Can you do 59?
Yeah, I'll do that 59. So let's take a look at it. Is that tangent 112.5?
Yeah.
And how'd you start it?
I don't know.
What formula did you use?
Oh, 1 minus cosine over sine.
Okay. I did grade your 10-point quizzes. I'll give those back here in a minute. All right, tangent 112.5.
I don't like writing.
Yeah.
I like math. I don't like that's like English person. No, she just goes over like random problems. We're supposed to be here today.
All right, those of you who just came, put up these answers here. Let me do this. Also, there's a couple options for 65, depending on if you went all the way to rationalize the denominator or not. So let me see here. I'll put this up and I'll freeze it over there. And that doesn't mean if you didn't get that for 65, doesn't mean you're wrong. Okay, but let me go through 59 here. We had a question. All right, so you got to do a tangent of 225 divided by 2. You got a half angle there. And so that becomes 1 minus cosine of 225 over sine of 225. Well, 225 is in which quadrant? Quadrant 3. And so the cosine and the sine will be negative. And so it's going to be 1 minus negative square root of 2 over 2 over negative square root of 2 over 2. Now here's where it just gets messy, simplifying and getting the proper form. And this is where I do think I see a lot of issues just dealing with fractions. Just adding them, dividing them, getting common denominators. That's probably the biggest mistake I see. Make this 2 over 2 minus a negative becomes plus, so it should be 2 plus square root of 2 over negative square root of 2 over 2. And now 2 plus square root of 2 over 2 times, that should be equals negative 2 over radical 2. Okay. The constant, the 2 and this 2 can cancel. You cannot cancel this square root with that square root because it's part of the expression. So you cannot do that. So you got to leave this as 2 plus radical 2 over square root of 2. All right. Now, for the most part, that's correct, but it's just not in quote proper form. So it does ask you to rationalize the denominator. So that's why if you got that, you're not necessarily wrong, but it doesn't match what they have. Okay. So if we want to get that, I got to rationalize the denominator. I'm going to multiply by square root of 2. Where'd my negative go? I should have a negative somewhere. We'll put that out in front. And now that gives me negative. Distribute that. And I get 2 square root of 2 plus 2 over positive 2. And now this 2 can cancel with both of those. And that's where we get negative. And then it'll be square root of 2 plus 1. And then if you distribute that negative, that's where we match that answer. So that's how you get that answer. But again, it's just dealing with fractions. There's just a lot of little spots to make a mistake. You just got to be careful, go back through and make sure, if you see something, go back and fix it. All right, any other questions there? All right, let me pass out your quizzes and guided notes.
You're close. Yeah, I was like, I don't know.
I'm feeling good about this class.
And we are on 6-5.
It's really bothering me.
Hey, the more 10 out of 10.
It's been a long time coming. That's right. I did.
That's the problem.
This is a long time coming. What do you say?
Watch me go on 5 on this.
On the formatting.
Maybe
make it for me. I'm proud of you.
Oh, it's Don.
That's good.
Oh, thank you. Good job.
Shoot. It's 120. On the test, I was like, that's 180. 6 times 2 is 180. Shoot.
Oh, literally has
Oh, shoot. Okay, so it goes.
There we go.
Yeah.
You know, I was and they try to a lot of them, it's actually just a lot of
Especially at work.
I kid you not, they're like 300 fighting.
Okay, there's a lot going on in this. Thank you. Okay, stop here. There's a lot going on in this chapter. You know, we start with identities. And then we move into like sum of difference formulas and half angle and double angle. And now we're gonna end with solving equations. Okay, so these are gonna be all trig type equations that we're gonna solve. You really gotta make sure you read the directions because they'll determine kind of how you answer. All right, so find the all values of x where x is between 0 and 360. Now on your paper, you got it worded just slightly different and you have the interval listed. Okay, this is typically the case is that you have 0 including 0 but not including 360. Those are coterminal angles. You never would want to put an answer of 0 and then another answer of 360. That's really naming the same angle. So when you see that, typically 0 is the one we use, not 360. All right, what angle has a sine of 1/2? Okay, so kind of go backwards. Josh? 30 degrees. What other angle has a sine of 1/2? Any other angles? Nope, that's it. Just 2 of them. Just 2 of them. So that's it. So 30 degrees. And 150 degrees. So, you know, you've been doing, like for the quiz tomorrow, I'll say what's the sine of 30, you'll say 1/2. We're just going backwards. Cosine of x equals square root of 2 over 2. What is that? Martin's on a roll.
It's 45 degrees and 315 degrees.
45 degrees because it's in quadrant 1 and also in quadrant 4. So you're going to have x equals 45 degrees and 315 degrees. All right, agreed. So you always want to think, all right, what quadrant, so this is where we get that other answer. Will it be positive or will it be negative? And then I usually think reference angle. So this has sine of x equals 1/2. Well, if you think unit circle, that has to be a 30-degree reference angle. And then we also have to know that that's going to be 30 degrees quadrant 2. So that's just degrees. Next one is in what? It's in radians. So you've got to give me the answer in radians. So it says 0 to 2 pi. Same thing as 0 is less than or equal to x is less than or equal to 2 pi. All right. Where is sine negative at? Where is sine negative? Well, it's positive in 1 and 2, so it's negative in 3 and 4. The opposite side is square root of 3 over 2. That means my reference angle has to be what? 60. Now I'm going to think in degrees, and you're probably going to do the same, and I'm going to write my answer in radians. That's absolutely fine. So 60 degrees here. So the actual angle will be 180 plus 60, which is 240. I'll convert it here in a second. And then it's also negative in quadrant 4. So that's going to be 60 degrees. What's that angle going to be? Jacob, what's that angle going to be?
8 pi over 6.
Say that again?
8 pi over 6 and 10 pi over 6.
Oh, just reduce them. Reduce those.
4 pi over 3 and 5 pi over 3.
Yep, so you actually went a step ahead. I just wanted you to say 300 degrees, but you went all the way to radian, which is fine. So 300 degrees, yes, you do need to list the answer in radians. It is a multiple of 30. It is a multiple of 60. Go with the highest multiple. 4 times 60, which means 4 times pi over 3. And then 5 times 60 gives you 300. 5 pi over 3. All right, typically sine and cosine are easier than tangent and cotangent and the others just because you are much more familiar. And it's really just kind of think about one triangle for that So tangent, sometimes you gotta think, all right, I gotta figure out what I need to divide. I think tangent of 1, though, you kind of have, for the most part, pretty good understanding. What is the reference angle when the tangent is 1? All right,
45.
45. Okay, because remember, for a 45, degree angle, this is where we get square root of 2 over 2, square root of 2 over 2. And so it is 45 degrees, which is pi over 4. And what other quadrant, Tony, is tangent positive in?
3.
3, and do you know what the other angle would be?
It'd be 5 pi 4.
5 pi over 4, good. So it's pi over 4, and then it is 5 pi over 4. Okay, so it'll be down there, 45 degrees. Okay, or 220. And then you got that third one there, secant of x equals 1/4. Don't think about secant of x, think about cosine of x equals 4 or 4 over 1. All right, you're either gonna get stuck here for a while or you know the answer right away.
No solutions?
No solutions, undefined, because you cannot take the cosine. There's the cosine of any angles between -1 and 1. Okay, undefined, no solution for that one. All right, what if you don't know the exact value? Sine of x equals 1/4. Is that a unit circle value? No. So what do? You pull out your calculator. So pull out your calculator. Unless you can do this one in your head, that'll be really impressive. Okay, so again, we're back to 0 to 360 degrees. Okay, for that one. When you type this in your calculator, all right, how do you type this in? Okay, make sure you understand that. Mackenzie Ward, do you know how to type this in to find the angle?
Inverse sine and then 1 over 4.
Inverse sine, correct, of 1/4, 1 over 4. That gives me, it doesn't give me that because I need to be in degrees. And 14.5 degrees, it will only give you one answer. There's another answer out there. Where's that other answer at? What quadrant? Quadrant 2. You're gonna have to find that. Okay, your calculator will give you one. Why does it only give us one answer? Because remember we went through this whole thing about inverse trig, why we had to restrict the domain so that when we did inverse of a number, we only get one answer back. So we only want one answer. So it's 14.5 would be the first angle. The second angle has to be in, this is not cooperating. Second angle has to be in quadrant 2. That's a very poorly drawn. Let's see if I can do this. Second angle has to have that as a reference angle. Now that's not the answer, so you guys take full rows. How do I find my second angle?
Not sure.
All right. That's the reference angle. Your second angle is this angle right to there. So you're not getting off that easy. What do I got to do to find that angle, the green angle?
Oh, subtract it, 180 from 180.
Yep, subtract it from 180. So you're going to do 180 minus 14.5. So on this case here, 180 minus 14.5, 165.5. So your two answers are x equals 14.5 degrees and 165.5 degrees. All right, let me go backwards just for a second. You can use your calculator. Like for these initial ones, like if you got stuck or if you just forgot or whatever, you could do inverse sine, or let me do that one. I could do inverse cosine of square root of 2 divided by 2. It will give me 45 degrees. It's not going to give you that second answer. You still got to be able to go figure out that second answer. All right. So for this next one, what do we got here? All right, cosine theta equals negative 0.75. Go ahead and type that in your calculator. Do inverse cosine. Negative 0.75. And quote to Luca, what does it give me?
138.6.
Okay, 138.6. That is going to be one of our answers. Aaron Hess, what quadrant will our other answer be in?
The other answer will be in quadrant 3.
All right. And any ideas how to find it? Aubrey's going to help you out.
Do 360 minus the 138.6.
You can do 360 minus that. Jacob, what were you going to say?
I was gonna say subtract 90 from it and then subtract that from 270.
So subtract 9. Okay, so you're going. That'll work. I don't recommend that for most, but I see what you're doing. Okay, because you're getting that angle and you're moving it down there, and then you're subtracting. There's a lot going on up here. Okay, but one thing you do is you subtract it from 360 because that is also going to be 138.6. So what is 360 minus 138.6?
221.4.
221.4. Now I will show you one other way, and other than Jacob's way. Jacob's way will work, but I would do this way. Is kind of the same format. Find the reference angle. What's the reference angle? Which is this angle right there. So take 180 minus 138.6. And that gives me 41.4. And that means this angle here has to be 41.4. And so to get your final angle, you would take 180 plus that. Okay. I see this used more than the 360 minus, but I really don't care. It makes no difference. They both give you the same answer. They're both correct. It's kind of whichever way you kind of visualize it will work. Okay, now this is the harder one because you're not as comfortable with this. Find all values of x between 0 and 2 pi. So we need to be in what? We need to be in radians. We need to have your answer has to be in radians. You're told to round to 4 decimal places. The book has you do that for radians. All right, sine of x equals negative 0.6. Okay, so do we know what that is? Like, is that a unit circle value? No. So you can't just sit there and figure it out. So put your calculator in radians. Well, first of all, here, before you do that, I'm going to do this. I'm going to hit inverse sine. I'm in degrees. I just want you to see this. Okay. It's really negative 36.9 degrees. Can't use that though, right? Because we need to be in radians. What quadrant is that in? In quadrant 4. Okay, because sine is going to be negative in quadrant 4 and also quadrant 3. So now I'm going to go ahead and at least have an idea where it's at. I got to go to my mode. I got to change it to radian. and I'm gonna hit inverse sine, negative 0.6. Negative 0.6435 radians is about the same as negative 36.9 degrees. Okay. That cannot be one of our answers, though. Why can't that be one of our answers? Like, if you list that as an answer, I got to mark it wrong. Check it.
It's not between 0 and 2 pi.
Thank you. It is not between 0 and 2 pi. Okay. We can make it between 0 and 2 pi, but the one thing you can't do is you just can't say, oh, my calculator gave that. I'm going to put that down. All right. It is in quadrant 4. Okay. That is going to be basically your reference angle. Okay. You don't necessarily need the negative at this point. It's going to be 0.64, what did I say, 35? All right. That can't be our, and if you just put 0.6435, that's wrong too, because 0.6435 would be in quadrant 1. All right. Do you know how to find what this actual angle is? Which would be this right there. Okay, Nathan?
Plus 2.
Plus 2? Where are you getting plus 2 at?
2 pi.
2 pi. All right, it has something to do with 2 pi. It does. All right, and if it is negative, I see what you're saying. You can either do plus 2 pi, okay, or you can take 2 pi minus if you drop the negative. Same idea. I see what you're saying. So that would be the answer. 5.6397. 5.6397. So that is one of our answers. So that is 5.6397. All right, where's the other answer? See if you can figure out what it is and how to figure it out. If you're not quite sure, just wait. But think where the other answer is. How would you figure it out? There we go. All right, I'm going to take. All right, Emily, you know where the other answer is? You know how to get it? Do you know where the other answer is?
No.
No. All right. Other answer, where's sine going to be negative at? What other quadrant?
3.
3. The other answer has to be in quadrant 3. Remember, these answers all have to have the same reference angle. All right. Do you know how to find the answer from here, Kevin?
No.
No. Emphatic? No. All right, and Libby. I mean,
Probably not.
right now. Serenity.
Pi plus 0.6435.
Okay, yes. This is going to be 0.6435. That is going to be your reference angle. And we are looking for this angle here. So that is going to be pi plus 0.6435, which I do not know off the top of my head. Pi plus 0.6435. And I get 3.7851. 3.7851. So my two answers are x equals 3.7851 and 5.6397. And that is an X. That's a bad X. Okay. 2 pi is about 6.28. So that kind of gives you a reference. So these decimals have to be between 0 and 6.28. All right, go ahead and find your first angle for tangent. So you get tangent of x equals 2.5. You just use your calculator. Think again, where is tangent positive at? It's positive in quadrants 1 and 3. Peyton Burns, what'd you calculate to give you 4 decimal places?
1.1903.
Okay, that is your first answer, and it is the reference angle. Okay, so you get 2 things out of that. Now it's positive in quadrant 3. So that needs to be 1.1903. And this angle will be pi plus 1.1903. And I don't know what that is. Pi plus 1.1903. 4.3319. And so I get my 2 answers of 1.1903 and 4.3319. Okay, for that. All right, now this third one, it does have solutions. It is not no solutions like the one up above. Okay, so cosecant, think about this as sine of x equals 1 over 6.4. All right, see what you get. Should get 2 values. Should get 2 values. All right, Grace, what'd your calculator give you for when you did inverse sine?
8.98.
8.98. Are you? Did you do 1 over 6.4?
Mhm.
You got some. Are you in degrees? Hopefully, huh?
Yeah.
Got any radians? Or you got to convert that to radians, one way or the other. Okay, so you got to have that answer in radians. Maggie Purdy, what'd you get when you put that in?
0.1569.
0.1569. So that's actually going to be our first answer. 0.1569. All right, how do I get my second answer? How do I get that one? Cooper.
Pi minus that value?
You're going to take pi minus that because your second answer is going to be, this is killing me here. This will be 0.1569, and so we're looking for that. And you want to take pi minus. And what do we get, Cooper, for that?
2.9847.
2.9847. Okay. Agree? All right. That's a hard one because you're not used to it. That's the hard one for that. All right, flip it over on the back. I think we're on the back. You might want to go back to degrees. You might want to go back to degrees. Okay. Are these directions different than the other directions?
Oh, I was gonna say it says radians and degrees.
That's part of it.
There's gonna be an infinite amount of solutions, but it's not defined.
Okay, there's an infinite number of solutions because it says find all solutions, and it doesn't say, now the other one did say find all solutions, but it just said between here and here. This does not give you a range. This finds every solution. There's an infinite number of solutions. All right, so how do we find them all? Okay, you can't list them all. We're gonna have to be able to come up with a method to do that. All right, well, first of all, start with the ones between 0 and 360. Okay, so for cosine of x equals square root of 2 over 2, let's just do degrees first, then we'll do radians. What angles in degrees have a cosine of radical 2 over 2? Okay, it's going to be quadrant 1. That one's going to be what? 45. And where's our other one going to be? You know?
Quadrant 4, 315.
All right, so you have 45 and 315. So here's what I'm going to do. I'm going to put down 45 degrees. I'm going to put down 315. How do I count for the infinite number of solutions? It repeats. It's a periodic function. What is the period of cosine? How often does it take it for it to repeat? Remember that.
2 pi?
2 pi, but since we're in degrees, it would be
365.
360. Every 360 degrees, it repeats. Every 360 degrees, it repeats. So I'm going to put plus 360 n for both of these. And now here's a little piece you got to do. You got to write down for any integer n, because technically n just can't be any number. Can't be 0.5. That would not work then. Couldn't be 0.75. It wouldn't work. It has to be 1, 2, 3, 0, -1, -2. All right, now just pay attention to this for 1 second. You don't need to write this down. So 45 would be the first one. Help me out here. Nick, you got your calculator. Add 360 to that.
45?
Yep.
That's just 4 over 5.
Add another 360.
765.
One more.
1125.
Okay. And now it goes left and right. And now we start with 315. So 315, add 360 to that. What's that going to be? 675. And then add another 360.
1035.
And add another one.
1395.
1395. All right, I'll come back to that in 1 second. There's a reason. All right, we said to put it in degrees and what else? Right. So for radians, here's all I got to do for radians. I just got to convert everything to radians. So x equals pi over 4 plus 2 pi n, and then 7 pi over 4 plus 2 pi n for any integer. Gotta restart. N. All right, so that's how you list all of them. Okay, and you just keep plugging in n equals 1, n equals 2, n equals 3, or n equals 0, n equals -1, n equals -2 for there. All right, part B. What's it say? Tangent. All right, tangent of x equals -square root of 3. All right, see if you can come up with the two angles. See if you can come up with the two angles first. All right, give you a chance. And you're allowed to use your calculator. So here's what I'd have you do. Make sure I would have you start between 0 and 360. There's another angle there. All right, so if you hit your calculator, what does it tell you? It says negative what? Inverse tangent, negative square root of 3. Hold on. I told you to go to degrees and I didn't. Gives you -60, right? So that's in quadrant 4. But that's the same as 300 degrees. There's another angle between 0 and 360 that also works. What is that other angle?
120.
This is 120, so it's got to be in quadrant 2. It has to have a reference angle of 60 degrees. It would be 120. Don't write this down yet. Just pay attention. So here's where we're at. X equals 120 degrees and 300 degrees. Jacob, do you remember what the period is for tangent?
Pi.
Pi. It is not 2 pi. It is not 360 degrees. It's 180 degrees. So still, do not write this down. So you would add 180n plus 180n. Somebody tell me, kind of, not necessarily an issue, but what happens here with our two lists? This starts at 120. What would be the next angle? 300. What would be the next angle? 480. The next one would be 580, 660, right? What would be the first angle here? 300 would be the second angle. 480, what would be the third angle? All right, so what did you just see? What happened? They're exactly the same, right? Are the ones above exactly the same? No, those are two unique sets of values. Okay, this goes 45, 405. That starts at 315. They do not overlap. They do not overlap. You cannot list both answers. You can only list the one. You only need to list the one answer. Use the smallest positive degree. And so that's why I said to wait a second. So we are going to, on this, just list 120 plus 180n for any integer n. That's only for tangent and cotangent, because cotangent has the same property. Okay, you only get one set of values. There you go. Now also I got it listed in radians. What is 120? 2 pi over 3 plus pi n. And that's, again, same thing for any integer. For any integer n. All right, so you got to be careful there. It says all solutions. Okay, it says all solutions. You got to do that. All right, we'll have to save those other two for tomorrow, but I do got a few problems for you. Sorry. I'll get to those other two tomorrow. Take off 41 and 47. I got a little anxious there. Yeah.